my good people, to today's wonderful edition in which we'll be considering sequences and series. So we'll be looking at a question in geometric progressions where the terms are given in form of algebraic expressions. So we're getting this from the 2016 paper 2, and the question says the first three terms of a GP or geometric progression are x plus 1, x minus 3, and x minus 1. So now we are required to find the value of x. So to find the value of x here, it is simply important to understand the concept of how the common ratio is calculated. And the concept of that common ratio is as follows. It is T2 divided by T1 should be equal to T3 divided by T2. So now, once you understand this, then everything will be easier. So now, going to our terms, we have got this is the first term, second term, and the last term, which is the third term. So this will simply mean this divided by this should be equal to that term divided by this term here. So we're going to have x minus 3 divided by x plus 1. This should be equal to x minus 1 over x minus 3. And then it must multiply. This will multiply this will multiply that. We're going to have x minus 3. Then you're going to have x minus 3 again. This is equal to x plus 1 being multiplied by x minus 1. So now we expand it. This will simply mean this, everything here multiplies everything here. And everything here multiplies everything there. So this will give us x squared minus 3x, then minus 3x, then plus 9. This will be equal to, coming here, we have got x squared, then you're going to have minus x, then plus x, then minus 1. So at that level, we simply simplify out what can be added out. So negative x and plus x, this will give us a 0, meaning those will be eliminated. So remain with x squared, negative 3x minus 3x will give us negative 6x, plus 9 is equal to x squared minus 1 there. So at this level, simply now put together terms with x, or the terms which have got the variable, and the constants, we'll take them on the other side of the equation. So we're going to have x squared minus x squared. This will become negative here, and we have got negative 6x is equal to this negative 1, and the 9 will also become negative 9. So the two will subtract each other out. So simply remain with negative 6x is equal to negative 10. Then you have over negative 6 over negative 6. So remain with x is equal to 10 over 6, of which the value of x is equal to, this will be reduced by 2 to give us 5 over 3. This is the value of x which they are looking for. Then coming to question B, which says find the first term. So the first term, we simply go to our question there and pick the first expression. This represents the first term. So we're going to have x plus 1 as our first term. So this will be x plus 1, and then we replace where there is x, we simply put 5 over 3. So we're going to have 5 over 3 plus 1 over 1. The LCM is 3. This will give us 5 plus 3, which will give us 8 over 3 as our first term. So this is our first term, which they're looking for in question B. Then coming to question C, which says find the sum to infinity. So now the sum to infinity is calculated by the formula which you know very well, which is sum to infinity is equal to the first term divided by 1 minus the common ratio. Now looking at what we have here, already the first term, which is a, has been found as 8/3. But the common ratio, we don't have it yet. So therefore, the common ratio can only be found if you know two consecutive figures. So now in this case, the second term is not yet known. So we should also find the second term, which is, here we have ax minus 3. So I'll simply find it here. X minus 3 will mean the value of x is 5/3. So we're going to have 5/3 minus 3/1. LCM there is 3. We're going to have 5 minus 9. This will give us negative 4/3. So this negative 4/3 is the second term. So now, to find the common ratio, we're going to use the second term and the first term to find the common ratio, which will give us common ratio is equals to negative 4/3 divided by the first term, which is 8/3. So the common ratio will be equals to negative 4/3 multiplied by 3/8. So the 3's will divide, and here 4 there is 1, 4 there is 2. Therefore, the common ratio is negative 1/2. That is our common ratio. So now, since the common ratio is now known, we can now replace in our formula for sum to infinity. So sum to infinity is equal to a, which is the first term. First term will be 8/3 divided by 1 minus, the common ratio is 1/2. So after that is done, we're going to have the sum to infinity is equal to 8/3 divided by 1 plus 1/2, and of which 1 plus 1/2, this is giving us 3/2. So now we have, looking at what we have here, this will give us 8/3. This is divided by 3/2. Okay, and finally, our sum to infinity will be, sum to infinity will be equal to 8/3 multiplied by 2/3, of which, therefore, sum to infinity is equal to, this is 16/9. This will be the sum to infinity. So the question C has been found. So by doing so, it means you have answered all the questions. Remember to subscribe and please hit the bell for new videos of such kind. See you next time.